If you haven't done so yet, pause the video and try to solve the question on your own before listening on. What we're going to do is draw a picture of this object that is accelerating horizontally. Now, initially, the 2 kilogram object is stationary, so of course that means that its initial velocity is 0 meters per second, and then it reaches a final velocity of 10 meters per second, so we can mark that as well. And then in order to calculate the work done in accelerating this object, we can consider using the work kinetic energy theorem, which of course tells us that work is equal to the final kinetic energy minus the initial kinetic energy. Now, since initially the velocity was 0, we can knock out the initial kinetic energy term. And so we would be left with just the final kinetic energy. Now that, of course, is equal to 1/2 times the mass times the final velocity squared. So all we have to do is go and plug in the known values. And when we compute that, we get 1.0 times 10 squared joules. So this would be the correct answer to part A. Now, to part B, in order to calculate the instantaneous power, we just have to consider the dot product between the force vector and the velocity vector. We recall that we can write the dot product as force times velocity times the cosine of the angle between the force and velocity. The force points to the right, and the velocity vector also would point towards the right. So the angle would be 0 degrees. The cosine of 0 is 1, so we can actually simplify this equation. Now, to proceed, we would need the force. We actually have the velocity at the 3-second interval that was given to us in the question as being 10 meters per second, but the force was not given to us. Now, of course, we recall that force is equal to mass times acceleration, so we can substitute that expression in for the force. The acceleration, of course, is the change in velocity divided by the time interval, so we can write the acceleration in this manner. The initial velocity, again, was 0, so we can actually eliminate that, leaving us with mv squared divided by t. So we'll just plug in the mass and the final velocity as well as the time interval of 3 seconds. And when we compute this power, we get approximately 67, and then the unit of power is, of course, watts. So this would be the correct answer to part B. Now, in part C, the final velocity actually is not going to be the 10 meters per second anymore, because now we're changing the time interval. If we look at the question, it's asking us for the first half of the interval, so that actually would be at time 1.5 seconds rather than time 3 seconds. So we actually need to calculate this final velocity at the end of the 1.5 second interval. Now we know final velocity is equal to initial plus acceleration times time. The initial velocity was 0, so we can eliminate that. We know the time, but what we don't have is the acceleration. So we're actually going to step back and calculate the acceleration by recalling that that would be equal to the final velocity minus an initial velocity divided by a time interval. Now, be careful here. To calculate acceleration, we can use the final velocity of 10 meters per second as long as we use a time interval of 3 seconds. The initial velocity, again, was 0. And so if we calculate that, we would get approximately 3.33 meters per second squared. That's the acceleration that's occurring in order to bring the block up to a velocity of 10 meters per second, but it's a constant acceleration. So we can use it for part C of the problem as well, even though that's asking about a different time interval. And so when we calculate that final velocity, we would get 5 meters per second. That's the final velocity that we're going to use when calculating the power. And so now we can return to the power equation, which is just the force times the final velocity. We can replace force again with mass times acceleration, and then we'll plug in the known values. And when we process that calculation, we get an instantaneous power approximately equal to 33 watts. So this would be the correct answer to part C. Thanks for watching the video. If you liked it, please click the thumbs up icon and subscribe to the channel. You can send in your own question to this email address, and I'll do my best to answer it on YouTube.